Hello, everyone. My name is Ana Gutierrez. Thank you for listening to my talk, which is the effects of light pollution on the vocal activity of a glasswork in urban conditions. Acoustic communication is the communication through sounds, so sending a message through sounds. And there are several factors that can affect this kind of communication. Noise and wind can mask the sounds produced by organisms. Also, temperature, humidity, and obstacles in a given space can affect the way sound waves transmit in that space. And daytime and nighttime hours affect the activity hours of both diurnal and nocturnal organisms. All these effects are increased in urban environments. For example, buildings and all human-made constructions are new obstacles that can affect the transmission distance of sound waves. Also, there's an increased temperature because of the urban heat island effect, which also affects the distance of transmission of sound waves. There's an increase in population and traffic, which causes noise that can mask sound signals produced by animals. And very importantly, there is an increase in artificial light sources, which causes light pollution, and it's what I'll be focusing on for this particular talk. So these lights that cause light pollution are all human-made. They have the characteristic of being brighter than natural lights. They're also more constant over time because they're on all night for the whole year. And there's also the reflection in clouds, which expands the problem way beyond of where the actual source of light is. This creates a perceived increase in daylight hours, which can cause changes in daily activity and behavior of several organisms, and this includes vocal activity behavior. So neurons are a good group to study light pollution effect because there's few species that have been reported to exist on urban sites. There's very little information on the subject for this group, but more so for the neotropical region. This is a group that is highly dependent on acoustic communication for their survival, and it's a group that is greatly endangered. So it is important to also think of light pollution as another stressor that can be contributing to this group's decline. So we chose glassfrog species, Yalinoatrachium fleischmanni, which is a good candidate for this research because, as most frogs, it is nocturnal. It lives and breeds in small streams in urban settings, and it's close to urban sites with different levels of artificial light, which makes the comparison between sites fairly easy. So with this in mind, we asked ourselves, what is the effect of light pollution on the vocal activity of Yalinoatrachium fleischmanni in urban conditions? And this is what we were expecting to find. So on the x-axis, we have hours of the day, and on the y-axis, we have the vocal activity. So we were expecting to find an overall difference in the vocal activity pattern throughout the night so that frogs would distribute the amount of calls differently in the night between dark and light places. And since this is a nocturnal species, we were also hoping to find that populations on light areas have their peak vocal activity later during the night. So we chose 3 sites. 2 of them are in a highly urbanized setting, and the third is in a suburban area that has more green remnants and more coffee plantations left. So as you can see on the figure on your right, we measure the average, maximum, and minimum light intensity in order to categorize dark and light places. So the average measurements for both maximum and minimum light intensities are very different between dark and light categorizations, as you can see. So after analyzing the recordings, we obtained a proportion of call activity per hour, as you can see on the y-axis and the x-axis. And what we found was that the pattern was different, the calling pattern was different throughout the night between light and dark populations. This is that the frogs are distributing the proportion of their calls differently in the hours of the night between light and dark places. So this was according to our predictions. But contrary to what we were expecting, the peak activity, the peak call activity for populations in light areas, it's earlier in the night compared to populations in dark areas. So what is the effect of this light pollution on frogs? We found an overall pattern that it's more similar to some diurnal birds that have been found to call earlier during the day because of the effect of light pollution. This could be a behavioral adjustment to account for permanently lit conditions that will resemble full moon night, just that the full moon would be every night for these individuals that are under permanently lit conditions. And this can also be a behavioral adjustment that reflects an effect of light pollution on circadian cycle. This has been found for different groups of organisms, different groups of animals, and it has also been related to a change in the seasonal calling pattern and an effect, a change on the starting and ending time of the breeding season. So this effect on circadian cycle can be also altering the way the activity hours during the night for this species. So with this results and this information, our next steps would be to compare body conditions between individuals in dark and light areas to see if this behavioral adjustment has an effect on the physiology of these individuals. And we also want to measure reproductive success, thinking that if this is a behavioral adjustment that it's happening in males, it should be in synchrony with the females in order to ensure that as a successful reproduction that lets them stay in these areas or survive in these areas that are more and more common every day because of the expansion of urbanization. Finally, I want to thank everyone that made this research possible. Thank you once again for listening to my talk. And if you have any questions, I'll be happy to answer them.